Hi, my name is Rik Layek, and today we will be performing an experiment on simple dipole antenna. We will see how we generate the report. So here it is. For first question, we have to show the antenna configuration and dimensions of the simple dipole antenna. So firstly we have to, this is the created report. So here we can check the dimensions for the arm 1 and arm 2. For arm 2 these dimensions, and we can also see the rectangular ports, and here for the second question we should see that you have to find the S11 characteristics. S11 characteristics. Go here for the S11 characteristics. This is the S11 characteristics graph. And let's take the next question. We have to find the resonance frequency. Resonance frequency. So this is the lowest point. This marker, lowest point. So M1 is the resonance frequency. From here we can see M1 has a 2.19 gigahertz frequency. It is the 2.19 gigahertz is the resonance frequency. From where we can find out. And let's look at the next question. So the question is upper cutoff and lower cutoff frequencies. So for upper cutoff and lower cutoff frequencies, and this is M2. From we can see two markers are there, M2 and M3. Here M2 is the lower cutoff frequency and M3 is the higher cutoff frequency. So these are the two, the lower cutoff and upper cutoff frequencies. Let's take a look at our next question. What is the antenna bandwidth? And for antenna bandwidth, we have to again look at these M2 and M3. Where is the higher cutoff and lower cutoff frequencies? We have to subtract the M3 minus M2 so that we can get the antenna bandwidth. Higher cutoff minus lower cutoff is equal to the antenna bandwidth. For fractional bandwidth, we have to do that FH minus FL divided by FH plus FL into 200. From that, we can get the fractional bandwidth. So let's take a look at the next question, which is the it's a variation of real part and imaginary part of input port impedance. From here we see that, yes, we have here this is the real part of the and the imaginary. From here we can get the imaginary part. Then let's take a look at our next question, the radiation patterns. So for this radiation patterns, we have to see radiation patterns. Let's take a look. Radiation patterns, to create the radiation pattern. Yes, it is the radiation plot. So this is the radiation plot we get, and this here, from here we can find out the. Let's take a look at the next question. Current and E field and H field, the current distribution. So from here we can to just simply go at our HFSS design. We have to select the part and then right click on it, and we have to simply plot fields E when shoot of E and click on done, and it will show, it will crash. It is crashing of mine. So again we have to open, I think. So here for the getting of our this, we have to right click and portlets and fields. We can from here we can get the electric fields, and here we can get the vector fields. We can also from H plot fields H mag H means magnetic fields. We can get the magnetic fields, and from here we can check the results from this. I can't show you because something is causing my HFSS to crash. If I show it, then better not I show it. This is the mag E. This is the vector. It will show the arrows pointing out and all that, and we can just click on it and field overlays, and we can also click on animate so that we can animate it. We can see it better visually. So, and let's take a look at our next question. From this, we have the to show the characteristics port impedance. So let's take a look at our characteristics port impedance. From here, we can click on analysis setup and matrix data. From here, we have to set 0 port impedance. This is our port impedance. As you can see, port impedance is there. And let's take a look at our next question. What are the radiated fields? Radiated fields, radiated field vector. So open HFSS. This is the um, this is doing the simulation, and this is the radiation field, and another one. I think this would be this, and this one. So these are the radiated fields. So thank you for watching.